Hello students, so here are the practice questions from selected questions from the textbook on exercise 10C. So let's take a look. Okay, so over here, right, it shows a quadrilateral ABCD. Then we are supposed to find the angle ADC, right? So to find the angle ADC, what we can do is we can recognize that this quadrilateral is made out of a rectangle like this. Okay, you follow my cursor, a rectangle, as well as a right angle triangle over here. Okay, so by making use of that fact, you can see the simple diagram that I actually sketched, right? We can actually figure out what is the angle ADC by applying cosine, because we already know the hypotenuse, which is 7, and the adjacent is actually the difference between the two lengths, right? 7 meters minus 4 meters is 3 meters. So 3 over 7, work it out, okay? The angle ADC is inverse cosine of 3 over 7, which equals 64.6 degrees. Now for angles in degrees, it's recommended that we round off to 1 decimal place, right? Finally, to find the length of BC. Now the length of BC is actually the same length as this one over here. You look at my cursor, right? It is the opposite length of the right angle triangle on top. We can use Pythagoras theorem. So this length over here is actually square root of 46.32, 3 centimeter figures. Okay. Next question. Here we have two right angle triangle, one inside another, right? So we are supposed to first find angle MLN. So MLN is over here. Okay. How do we do that? Let's take a look. Okay. To find that, the first thing we want to do, right, is take a look. We can find MN first, right? NM, we can use the smaller right angle triangle over here because we already know 38 degrees. Okay, so cosine 38 degrees here is actually NM over the hypotenuse 9.2. Therefore, NM is 9.2 cosine 38 degrees. Okay, but we don't need to work it out yet. If you want, you can make this equals to a certain value, but please ensure that it is 5 significant figures or more. Otherwise, if you leave it in this form for the time being, it's actually fine, right? So once we got NM, now we can look at the larger right angle triangle, right? And says that sine MLN, which is this angle, is opposite over hypotenuse. The opposite is NM, hypotenuse 15.5. So we replace NM with the 9.2 cosine 38, which we have found. And then the angle itself is sine inverse of this ratio, which gives us 27.9 degrees. Okay. Second part of the question, they want us to find HL. So to find HL, if you are in upper secondary, you'll probably use what we call the cosine rule. But if you are in Sec 2 right now, which most of you watching this video probably are, then you have not learned the cosine rule, so your working is slightly longer, right? So what we need to do is we need to find NL first, right? But there is a technique that you will learn in upper secondary where you do not need to find NL. There's a way to find HL directly using something called the cosine rule. Those of you who are interested, you can always look for me and I can teach it to you. No issue with that, right? So NH is 9.2 sine 38. Again, using the triangle NHM, we can do that. So we got NH. So NL, okay, is actually 15.5 cosine this angle, right? Because this is the angle MLN. We already have that from part 1. So now if you use cosine, we can find NL. So what we do, our HL is actually NL minus NH, right? So NL minus NH, right here. So once we have the expression right, replace the angle MLN with our answer from part 1, and then press the calculator carefully, we should get 8.04. Right? So the idea is you find the length NH, you find the length NL, and then after that, find the difference. Okay? That's one way you can do this. Right? Question 5. Here's another one, similar type of question to the earlier question. So we are supposed to find QPK, right? QPK is this angle. Now to find this angle, what we can do is we can actually find the angle, okay, PQR, then find the angle KPR, and then find the difference. That's one way we can do this. Alternatively, actually, there's another method in upper secondary where we use something called the sine rule to find these type of questions. Once again, if you're interested, you can look for me. If not, well, you will learn it in Sec 3 in upper Sec, right? So here's what we do. Okay. First, okay, we find the angle KPR. So KPR, okay, we can use the cosine ratio because we know the adjacent 7.6, we know the hypotenuse 17.4. So use cosine ratio, we find that it is actually 64.1 degrees, right? So after that, what happened? We need to subtract, okay? We need to subtract this angle over here, KPR. What is KPR? Well, remember there's this property called the exterior angle of triangle is actually equals to the sum of the opposite two interior triangles. So 137 over here is actually 90 degrees plus this angle over here, KPR, right? So KPR is actually 137 minus 90, which equals 47. Then after that, we find QPR using the cosine ratio. Then we find the difference. So the answer is actually 17.1 degrees. Okay. And finally, to find the length of QK, okay, same idea as the previous question. It's actually QR minus QK, right? So QR is actually, okay, 17.4 sine this angle over here, right? Because if you use this angle, 64.1, we know that this is opposite over hypotenuse. So using the sine ratio, we know what is QK in terms of the other information. And then we can also find KR, right? KR using the triangle PKR, right? We can actually use tangent. So tangent 47 degrees, right? Which is this angle over here. Is actually KR over 7.6. So KR is 7.6 tangent 47. Press our calculators properly, we get 7.50 meters, three single figures. Okay, so that's exercise 10C. I hope you are successful. Have a nice day.